Good evening, everybody. Good evening. Am I audible there? Am I audible? Someone can give a consent. Someone
Yes,
can
ma'am.
respond. Please.
Yes, ma'am. You are audible.
Thank you. Yeah. Thank you so much. The course which we'll be doing for another 7 or 8 days is operations research. 1 minute. Just give me a minute. Yes. Once again, good evening. The course is operations research. Okay. So let us quickly embark into the course by giving a small introduction. I'm Dr. Sushma. I'm working for St. Pius X MBA College for Women. Okay, so I'll be the facilitator for this course for another 9 days, right? So we'll be having classes from 7 to 8 in between, and I'll be sharing my whiteboard and I'll be solving the numericals, and also I'll be sharing the PDF which was given to me by the coordinators there. Okay, so this subject is it's there for the other universities as well, operations research. So it is sometimes called as quantitative techniques for decision making also. So operations research is basically it has its origin during the Second World War. Okay, so why during the Second World War? Because during wartime, what happens usually? There is a warlike situation, and countries are fighting for their existence, and you have shortage of resources. Okay, suppose if I get a doubt or idea sometimes that if we would have had abundant resources, we wouldn't have had this many subjects into existence only. Like for say, economics wouldn't have been there, management wouldn't have been there. And management, we talk more about optimizing the resources, optimizing. So what is this term optimizing? Okay, so using the making use of the resources in the best possible way is known as optimization. Optimization can be maximization, it can be minimization, depending on what criteria you're talking about. Okay, maybe I'm used to use the chalk and talk method. So I'll be sharing 1 minute. I'll be sharing, yes, I'll be sharing my whiteboard so that I can scribble on that. Okay. So you can note down that also, whatever we will be discussing on today, right? So I'll be starting with the first unit, which is to do with one of the techniques of OR. Okay, but let us go back to operational research. Okay, so its origin was during Second World War, when really countries were fighting for the resources. Okay, so the statisticians, they were finding out ways and means how to allocate these resources to the best possible use. Okay, best possible use. That's why this operations research has come into. So it's research on the military operations, basically, to do with. Okay, so later, this is how the term operations research has come into existence. Operations research. Operations research. Is my whiteboard visible to everybody?
Yes, ma'am.
Okay. So, like for just for testing, what did I write on my whiteboard?
Operation research.
Okay. Thank you so much for confirming. May I know your name?
Santu.
Santu. Okay. Thank you, Santu. Right. So, operations research has come into existence during Second World War. This, of course, it is there in your study material. You can go through. And first unit also talks about operations research and its relation with other subjects. Okay, other subjects. So, like, you don't have any subject independently existing. Okay, it's always linked with other subjects. So as operations research also, it is linked with other subjects. Like, it is linked with economics, it is linked with finance, it is linked with marketing. Okay, so the link between operations research with other subjects, you can go through the theoretical part. Okay, so in the first unit, apart from introduction of operations research, it's history, historical background. Also, they talk about one of the important techniques of operations research, which is linear programming problem, LPP. It is called in an abbreviated form as LPP, linear programming problem. Linear programming problem. So we will go into the depth of linear programming problem. Okay. So linear programming problem, linear. So what do you understand by the term linear? Linear. Is this a linear one?
No.
No. Right. Is this a line?
No.
No. Is this a line?
Yes.
Yes. Okay. So linear has its origin again from the term line. Okay, line. So here basically, whenever we talk of solving a problem, in mathematics also you must have seen in your school days, whatever maths you must have learned, and I believe everybody has gone through the school, right? And everybody has learned the mathematics. Okay, in mathematics, we take some variables. Okay, so what do you mean by variables? These variables take the values from the outcome of some experiment. Okay, it doesn't have a fixed value. It takes the values from something else. Okay, so here also in linear programming problem, we talk of decision variables. Decision variables. See, as we have already seen, operations research is about taking an optimal decision. Okay, so you are talking of given circumstances. Under given circumstances, what is the optimal decision I can take? So as a manager, we have to think of many a times. Maybe someone is sales manager, we have to allot some salesmen to different markets. Okay, so how do I allocate the different people to different markets? Maybe as a teacher in my college, I encounter with the problem of making a timetable. Okay, maybe some have given constraints. Everybody has given their constraints. See, I perform a puja on Friday, so please don't allot me first star. Okay, someone can say that I don't want to take a first star on Monday morning. I have Monday morning blues. Someone can say that please keep me free on Saturdays. Okay, so that I can avail the leave on that day. Okay, so you have so many constraints. Amidst that, I have to decide about the timetable. Okay, that is my problem. Okay, or some student might encounter a problem like he must be getting some pocket money. Okay, say he must be getting a pocket money of 1,000 rupees a month. Okay, so he has, let us keep this example quite simple. Okay, let us think that he has only two things to buy. Okay, spend his money on. Okay, what can be the two things you can think of as a student? He's a student. The hypothetical example, we have taken it of student. Okay, what are the two needs he must be having? Maybe perhaps his exams are nearing. He might have to buy some books. Isn't it a need? Yes.
Yes, ma'am.
Okay. And then what can be the other need? So to keep the example simple, I'm taking only two needs. Okay, the student can have many needs, but let us keep the example quite simple. Let us take only two needs. Yes.
Entertainment, madam.
Entertainment, very good. Maybe he wants to see movies, right? So now his decision variables are only two. Okay, let us say that let the number of books he buys is X. Number of books he buys is X. Okay, number of movies he can watch is Y. Okay, suppose if there is no constraint, suppose RBI's chief is his father. Okay, he can avail as much as money he can use. Okay, he doesn't have any limit on the money. So do we have to solve this problem really? Like, do I have to tell him that he can purchase only 5 books, he can watch only 2 movies? Do I have to do that? No. Actually, the problem has come into existence because you have limited resources. You have limited resources. Under those limited resources, how are you going to allot those limited resources to these decision variables? Okay. So at the end of the solving of the problem, I should be able to tell to the boy, or perhaps the whole class, whoever is there in the today's meeting, they should be able to tell to that student what are the values of this X and Y. Is that clear? So this is what we are going to do today. Okay, we will formulate a problem and then we will talk of how do you solve the problem. Okay, what do you mean by formulation of the problem? We are just forming it. Okay, someone has come to me, he has explained his problem. Okay, he said, see ma'am, I get 1,000 rupees. Okay, I have to watch movies, I need some books. Okay, and since because these books are not available in library, I need to compulsorily purchase these 2 books. Other books I can borrow from library. Okay, and one of my favorite stars is say, I'm not well versed with actors, uh, maybe some Telugu star, Mahesh Babu. Okay, my favorite star is Mahesh Babu. His movie has released now. I have to compulsorily see that movie, right? So these are some of the constraints he has given me. Okay, so amidst these constraints, I have to solve the problem so that he can use that 1,000 rupees to the maximum possible extent of satisfying this student. Is that clear? So in a problem, we have decision variables. Here, in this present case, we have 2 decision variables, X and Y. Suppose he has certain other needs also, we can add the variables X, Y, Z, or ABCD, or ABCD, or LMNO, whatever you want, you can use the variables names. It's up to you, right? So in the present example, we have taken only 2 needs. They are known as decision variables. Okay. So these decision variables are literally fighting for the resources. Don't you think? Suppose if he buys more number of books, won't the number of movies reduce? Won't the number of movies reduce? Please, yes or no will confirmation, a small confirmation will be, I'm saying assured that you people are listening.
Yes, ma'am.
Yes, if the number of books increase, number of movies will decrease. Okay, so these two are fighting for the same resource, that is 1,000 rupees. Okay, so these decision variables are fighting for the same resources. Okay, in this present example, it is the money. Okay, now it can be some other resource also sometimes. Okay, so now first we have started with telling what are the decision variables. Okay, next I'll tell you, this boy, after spending the money, he gets a certain level of satisfaction. Though satisfaction is not measured in terms of no measurable, no unit is there which can properly measure the satisfaction, isn't it? I can't say that I got 5 kgs of satisfaction, or I got 10 meters of satisfaction. Okay, so you don't have any proper measure of satisfaction, but still Some economists have tried to measure the utility or the satisfaction in terms of the unit known as utils. Have you heard of this? Utils? Yes. Did you hear of this word, utils? Utils is the level of satisfaction or the amount of utility you get from consuming a particular product. Okay. After consuming a particular product, you get certain level of satisfaction. This is measured in terms of utils. Okay. Now, these things are given to us by the student. He has provided us some extra information. He says, ma'am, one book I read, I get a satisfaction of 10 utils. 10 utils. And one movie I see, I get a satisfaction of, let us make it a little more, because movies give you more satisfaction, isn't it? Okay, 50 utils. Okay. So now, every problem, whenever you are formulating a problem, you talk of optimizing. Here, optimizing will take two meanings. Optimization will take two meanings. What are the two meanings? Maximization or minimization. Maximization or minimization. In the given case, will the maximization will be applicable or minimization is applicable? Do we have to maximize the satisfaction or do we have to minimize the satisfaction? Do we intend to maximize the satisfaction? Suppose the criteria is cost. Okay. I want to minimize the cost. Suppose the criteria is time taken to finish a job. I want to minimize the time taken. Okay. Suppose the criteria is contribution or sales profit. Okay, profit. Okay, I want to maximize the profit. Suppose I want to, the criteria we are deciding is employee attrition. Employee leaving your organization is known as employee attrition. My criteria is employee attrition. I want to minimize the attrition. I don't want people to leave my organization and go, isn't it? So the optimization can take two meanings, either maximization or minimization, depending on what you're talking about. Here we are talking about satisfaction. That's why it is taking a meaning of maximization. Is it clear? Yes? Is it clear?
Yes, madam.
Yes. So now let us try to formulate a problem for him. Okay. So how does it start is formulating a problem is we have to, now he has defined the problem in terms of English language or Telugu or whatever in language he has given. Okay. He told me that one book I read, ma'am, I will get 10 units of satisfaction. One movie I see, I get 50 units of satisfaction. And 1,000 rupees is what my father gives me every month. Right? And in this, you tell me, ma'am, how many movies should I watch and how many books should I read? How many books should I buy? Okay. And I have one more constraint, ma'am. 2 books are there which compulsorily I need to buy, ma'am. Okay. 2 books I have to buy. And one movie of my favorite star I have to see. Okay. So let us fix up the cost also. One movie, I know movie prices have increased like horribly, but let us assume for our simplicity, one movie costs you 200 rupees. Yes? One movie costs you 200 rupees. Okay. And one book costs you rupees 100. Rupees 100. Okay. All the movies you see, irrespective of how you have booked the tickets or which theater you are seeing, let us keep the example simple. One movie costs you 200 rupees. One book costs you 100 rupees. Okay, so this is the data we have. Now we have to formulate a problem. Okay, just form a problem. We don't solve it. We will just form it today. Okay, so how do you form the problems? I guess you people must be noting down the data, isn't it? Yes. I'll be asking from you people only. Okay. Now, yeah. So now the problem starts with the objective. Objective is denoted by the letter Z, capital Z. Okay. So before Z, you have to write Maximize Z. What is the objective of formulating and then solving the problem? We want to maximize the criteria. What is the criteria here? Satisfaction. What is the criteria here? Satisfaction. Okay. So how do you find out the total satisfaction derived by the student? Okay. One book is giving him how much of satisfaction? How many utils?
10.
10.
10, ma'am.
But how many books are you buying? Aren't you buying X books?
Yes.
Yeah, we are buying X books. So one book is giving you 10 utils of satisfaction. X books are giving you 10x units of satisfaction. Is it clear, correct?
Yes, ma'am.
Yes. So maximize Z is equal to 10x. Is he getting satisfaction only because of books or something else also?
Movies.
Movies, right? One movie is giving him how many units of satisfaction?
50.
50. But how many movies are they asking him to watch? Why? Isn't it? Still we haven't determined. That is what we have to determine. Isn't it? So for Y movies, how much satisfaction will that boy get?
50Y.
50Y. Very good. So can I write maximize Z is equal to 10x plus 50Y? Isn't it giving the total satisfaction which he is deriving?
Yes, ma'am.
Yes. Okay, I'll just erase this. Again, I'll write down the objective. So your objective is maximize Z is equal to 10x plus 50y. What is this? 10x is the satisfaction which he gets because he reads books. 50y is the satisfaction he gets because he watches movies. So this is his total satisfaction which we want to maximize. Isn't it? Yes or no? Yes?
Yes, ma'am.
Yes. Then subject to. Why we are writing subject to? Every problem, I have begun the class by saying that had resources been available in abundance, these subjects wouldn't have come into picture only. Okay. We have problems, we solve the problems. Problems doesn't mean only the numericals what we solve. I mean the problems in life, problems in organizations. Okay, that arise because we have limited resources. Okay, because we have limited resources, isn't it? So sometimes we think that even time we had a day we have been got 36 hours, I would have finished all my jobs on time. But no, day has only 24 hours, right? So we fall short of resources. We fight for the resources. That's why these problems are there in life, right? So subject to some constraints. So constraints are the limitations because of which these problems are there. Okay. So subject to, what are the constraints here? Isn't 1,000 rupees a constraint? Yes.
Yes, ma'am.
Yes, 1,000 rupees is a constraint. Isn't it a constraint that he has to watch his one movie of his favorite star? Isn't it a constraint? Maybe some constraints are there which we have imposed on ourselves. Okay. So he has imposed a constraint on himself that one movie I have to pakka watch. Okay, it can't be zero. It can't be zero. This Mahesh Babu's movie I got to watch at any cost. Okay. And because some books are not available in the library, doesn't he have a constraint of buying those books compulsorily? Otherwise, he'll fail in exams. Isn't it? Yes? Are you understanding the point? So there are three constraints we can think of. In normal life, maybe you will have many more constraints, which we are not talking about here. See, this was a hypothetical example of a student. It can be a real life example wherein maybe a carpenter has to decide how much wood will he allocate to table and how much wood he will allocate to make a dining table. Okay, normal teapot and dining table, so that he maximizes his profit. Okay, someone else can have a problem like how many advertisements should I place in Instagram, how many advertisements should I place in maybe TV channel, okay, so that my reach is maximized. Okay, so you can think of many problems which you can formulate in the form of a linear programming problem. Okay, so here we'll try to write the constraints now. Okay, subject to, okay, for one book, how much he has to spend?
100 rupees.
100 rupees. But how many books is he buying?
10 books.
No. He's buying X books. He doesn't know how many books he has to buy, right? It is X still. We didn't solve the problem for him. Okay. So one book he is buying, he has to spend 100 rupees. But how many books is he buying? X books. For X books, what will be he's spending? How much he has to spend?
100x.
Very good, 100x. Similarly, on movies, how much he'll be spending?
200 rupees.
200 for one movie. Okay, 200 for one movie. But is he watching only one movie?
Why
How many movies
movies?
is he watching?
Why movies?
Why movies? So how much he has to spend?
200 why?
Very good. Okay, so 100x he is spending on books, 200y he is spending on movies. This is his total spending. Total spending. Can he spend more than 1,000 rupees?
No.
No. Can he spend equal to 1,000 rupees?
Yes.
Can he spend lesser than 1,000 rupees?
Yes.
Yes. Right. So based on your answer, I'm writing an inequation here. Less than or equal to 1,000. Is this constraint correct?
Yes.
His total spending should be less than or equal to 1,000. So this is one constraint. This is one constraint. Is that clear?
Yes, ma'am.
Yes. And minimum, he has to see that one movie, isn't it? Whenever we say minimum, it means the number can be greater than or equal to 1, isn't it? So number of movies, that is y in our present example, should be greater than or equal to 1. Isn't this a constraint?
Yes.
Yes. One more constraint we have put is number of books should be minimum 2, isn't it? 2 books he got to buy. Those are compulsorily he has to buy because those are not available in the library. Okay, so X is greater than or equal to 2. Is that clear? These three are the constraints. In brackets, actually, you describe the constraint in English. Okay, for the first constraint, you can write his pocket money. Second constraint, you can write his favorite movie stars movie is released. Third constraint, you can write down in the brackets that those books are not available in the library, because of which he has constraints. And one more constraint which is there for all the problems, all the linear programming problems. Okay, what is that constraint? I'll ask you one thing. Can I buy -2 books?
No.
No. Can I can I watch -5 movies?
No.
No. So X and Y has to be greater than or equal to 0.
Yes.
Yes. So this constraint will be there for all the problems, right? So this is known as non-negativity constraint. Non-negativity constraint, because decision variables can't be negative. I can't manufacture -5 tables. I can't allot -5 salespeople to particular market. I can't. Okay. So decision variables will take, at the most, it can take 0 value. Okay. I can buy no books at all. 0 books I can buy. Okay. But in this given problem, X can't take the value of 0 also because of this constraint. It has to be equal to 2 or greater than 2. Okay. Y can't take 0 value because it has to be greater than or equal to 1. Okay. So now this is the problem we have formulated for this boy. Okay. What is the problem we have formulated for the boy? Maximize his satisfaction. Maximize his satisfaction. Subject to we write down as ST. Okay, we call it as subject to. Subject to what constraints? Constraints are 100x plus 200y less than or equal to 1000, x greater than or equal to 2, y greater than or equal to 1, x comma y greater than or equal to 0. So this is the problem we have formulated. Is this problem
Madam,
clear?
madam,
Yes, sir.
hello.
Yes,
Here
sir.
we need not mention that non-negativity constraints because the conditions subject to the conditions themselves states that.
Yes, that's true, sir. But it's a ritual or customary to give non-negativity constraint, usually. Okay, because based on the non-negativity constraint, we limit ourselves when we are solving this problem by graphical method. Okay, this particular example, I have given this 2 constraints. Suppose if these 2 constraints are not there, don't we have to write down x and y greater than or equal to 0 in that case? We have to write, because if you take only this in equation, you can have some negative values for that. Also, this equation can be true. Okay, but that can't take that x and y can't take those values. Okay, so non-negativity constraint is basically from the it's a custom to give the non-negativity constraint. Okay, it will be there invariably for all the problems, sir. Okay, is that clear? Yeah, as you have said, it is correct. Because of these 2 constraints, non-negativity constraint seems quite irrelevant here, but it's more of a custom to write non-negativity constraint. Okay. So is the mathematical formulation of a problem clear? Mathematical formulation of problem, is it clear?
Yes, ma'am.
Yes. And why it is known as linear programming problem? If you have seen all the equations, whatever we have given, see, z is equal to 10x plus 50y, it's a straight line equation, isn't it? Yes. Suppose you have x square plus 2xy, then this becomes a curve. Okay. If you have something in x and y only, then it will be a straight line only. Okay, it will be a straight line. Okay. So we are making a subtle assumption that whatever variables we are taking, they are related to each other in a linear fashion only. Linear fashion only, so that all the constraints objective can be drawn as a line on a graph sheet. Line on a graph sheet. Okay. So let us see these 3 terms. Linear programming problem. Linear, why linear? Because decision variables are connected with each other in a linear fashion. In a linear fashion. Okay, programming. Programming is more to do about the planning. Okay. We are doing planning. We are formally trying to resolve the problem. Okay. So that's why programming word is there. Okay. Linear programming problem. And of course, it is a problem. So it is problem P is there, right? So linear programming problem has some decision variables which are connected with each other in a linear fashion, so that we can solve the problem, and at the end of the solving the problem, you should be able to tell to that boy how many books he has to buy, how many movies he has to watch. Okay, is that clear? Our objective is that. But in linear programming problem, the x and y are divisible in nature. What do you mean by divisible in nature? I can get an answer that I have to see 1.25 movies. Possible. I will get such an answer. To overcome this, there is one more programming technique which is known as integer programming. Integer programming. What do you mean by integer? It's a whole number. Okay. So 5 is an integer. 5.5 is not an integer. Okay. So in integer programming, this drawback is overcome. Okay. So x and y, if they are divisible in nature, okay, we can go for integer programming also. Okay. But integer programming, it is not covered in your syllabus except for some just small touch up is there about integer programming. Other than that, it is not discussed elaborately. Okay. So linear programming problem, you should not worry if you get an answer something like this. Okay. So watch 2.5 movies, watch 1.25 books, buy 1.25 books, quite possible because x and y are divisible in nature. That is one drawback of the linear programming problem. Okay. Is the formulation clear to everybody? Is the formulation clear to everybody? Yes.
Yes, ma'am.
Yes,
Yeah.
ma'am.
Can I test your understanding a little?
Okay, ma'am.
What are x, y known as?
Variables.
What variables? Decision variables. Okay, they are known as decision variables. Okay. Now, how the objective is denoted? Objective function is denoted by which letter? Objective function is denoted by which letter?
Z.
Z. Yeah, capital Z. Okay, before Z, we write something. We write either.
Minimize or maximize?
Very good. Maximize or minimize. To write maximize or minimize, how do we decide that? How do we decide whether we write maximize or minimize?
Maybe in the question it is given now.
Yeah, based on the criterion given, if it is satisfaction, will it be maximize or minimize?
Satisfaction, it should be maximize.
Maximize. If it is cost,
Cost, minimize.
Minimize.
if it is time taken to do a particular job,
Minimize.
minimize. If it is dissatisfaction levels,
Minimize.
minimize. Very good. Okay, so objective function, objective of formulating and then solving the problem can be maximize or minimize the objective function. Here, objective function is denoted by Z. Okay, it is a function which connects both the decision variables through some constants. Okay, so you have 10x plus 50y. Okay, these are the decision variables and these are the constants per unit factors. Okay, per unit, it can be per unit profits, it can be per unit sales revenue, it can be per unit of time taken, anything. Okay, so subject to some constraints. Okay, so you have to write down all the constraints followed by the non-negativity constraint. So this we have formulated the problem. Okay, we have formulated the problem. Is the formulation of the problem clear to everybody? Formulation of the problem is clear to everybody?
Yes, ma'am.
Yes. Now, formulation itself isn't enough. See, what we have done in formulation, that boy has told the problem in some language, we have converted into mathematical form. We have converted into mathematical form, having some inequations, equations, everything. Okay. But now we got to solve it. We got to solve it. Okay. And tell him the values of x and y. Then our exercise is done. Right. We have accomplished our exercise only after telling him how many movies he has to watch and how many books he has to buy. Right. With the 1,000 rupees of money which he has got. Okay. Solution. There are basically two methods to solve. One is graphical method. As the name implies, we solve it on a graph sheet. Next, one more method is there, simplex method. Okay, though the name simplex is given, It is little complex method only. Okay. So simplex method is there. I don't know how I'm going to solve it. Maybe I will connect it through my laptop. I will take the class from the laptop so that Excel sheet will be a better option for me to write. Okay. Tomorrow I'll do that because my whiteboard on my phone is quite a small one. I won't be able to do that on this. Okay. So there are two methods, graphical method and simplex method. Okay. Graphical method has its own limitation. How many axes does a graph sheet has? How many axes does a graph sheet have?
Two.
Two
axes.
Two axes. Two axes.
External.
Suppose if number of decision variables are two, only two, then this will be helpful. Graphical method is helpful. Suppose if he has three needs, okay, he has the need of books, movies, and say he likes to, he's a foodie, he wants to go out and have food somewhere out. Okay, he has three needs, we can't solve it on the graph sheet. Okay, so graph sheet we have only x-axis, y-axis. So if number of variables are two, we are able to solve it on a graph sheet. Otherwise, we have to go for simplex method. Okay, is it clear?
Is it
Yes.
simplex method is only for 3 or more than 3 months? More than 2?
Simplex method can be done for two also, sir.
Okay, ma'am.
Simplex doesn't have any limitation. It can be used for 2 variables, 3 variables, 4 variables, any number of variables. Okay, but because of paucity of time, they may not give you a lengthy problem in a exam. Okay, exam point of view, they might be giving you very few constraints and few variables. Okay, because simplex method, you go into iterations. Okay, until you get, see, there are only step 1 to step 5. Okay, so if you don't get 3, 4, 5, okay, if you don't get the answer here, again you repeat the steps. You do the iterative process in simplex. Okay, so you may have to do quite a many number of times. The whole 3 hours will be gone to solve only one numerical. So they usually don't give such a big numerical with many variables. Okay, are you understanding?
Yes, ma'am.
Yes. Okay. So here in the first unit, you might get that actually runs into the second unit. First unit, you have linear programming, introduction of OR, and linear programming problem formulation only, which we have done with an example, a hypothetical example. I think I can share the your material here so that I can show you. 1 minute. Is my screen visible?
Yes, ma'am.
Yeah. Here, let us see what formulation problem he has taken. I hope everybody has the material with you also, right? How many participants are there in the group now?
13, ma'am, including you.
Okay. But nice. Last time I had taken a subject, it wasn't so interactive. This interaction is good. Yeah, 1 minute, I'll show you.
We are also liking your teaching, ma'am.
Thank you so much. Yeah, you can see here, he has given a diet problem. Okay, I hope everybody nowadays can relate with the diet problem. See here, a diet problem is given. Are you able to see the problem? Yeah. Yeah, a customer is trying to select the optimal combination. Again, the word optimal, you can underline that in your material. Optimal combination of 2 foods to meet daily vitamin requirements. The vitamin needs call for at least 40 units. See, this is the constraint. Means you have to take vitamin W at least 40 units. Okay, at least 40 units. And 50 units of vitamin X and 49 units of vitamin Y. So these are constraints. And each, are you taking vitamins directly? No, you are taking it through some food. Okay, what are the food available? Food A is available, and so each gram of food A gives you 4 units of vitamin W, 10 units of vitamin X, 7 units of vitamin Y. Each gram of food B provides 10 units of vitamin W, 5 units of X, 7 units of Y. Food A costs ₹5 per gram. Food B costs ₹8 per gram. Find the least expensive way to satisfy vitamin needs. See, whatever the question is being asked, that is your objective. Okay, last line you can underline. Find the least expensive way to satisfy vitamin needs. Means I have to get the requisite vitamins, but I should not spend more. Okay, that is my objective. So your objective function is minimize. Minimize what? Minimize the cost. Okay, so you have to start identifying the variables. Okay, first you have to write that let A be the amount of food A you are consuming, and B be the, or X and Y also you can use. But here, because he has used X and Y for vitamins, we can use A and B only. Okay, so you can see here. See, each for 1 gram of food A, how much he has to spend? 1 unit of food A, how much he has to spend for 1 gram of A?
4.
5 rupees.
5 rupees.
5 rupees. So how many grams of A he is buying? A. Let us think A. Okay, for A grams, how much he has to spend? I will parallelly take my whiteboard also. Okay. Yeah. See, he has given. So we have to write let A be the number of grams of food A. Food A. Let B be number of grams of food B. Okay. So we have defined the variables. Okay. Now at the end of solving the problem, you should be able to tell to that person who is following this diet planner how many units of A should you buy and how many units of B should you buy. Okay. 1 unit of A costs you ₹5, isn't it? Yes or no?
Yes, ma'am.
Yes. But how many units, how many grams you are buying? A grams. So A grams, how much you have to spend? 5A, isn't it? One gram costs you 5 rupees. A grams costs you how much? 5A, isn't it?
Okay, ma'am.
Yeah. Are you spending only on A, food A, or B also?
B also.
B also. B, for on food B, you are spending 8B, isn't it?
Okay, ma'am.
Yeah. So this is the total spending. This is the total spending. Okay. So this you want to minimize. So your function is minimize the total cost. Z here is total cost. How much is the total cost? 5A plus 8B, isn't it? Yes or no?
Yes, ma'am.
Yes. Subject to what constraints? You have some minimal vitamin constraints. Okay. So those minimal vitamin constraints are taken care of here. See here. For vitamin W, how much is the minimum vitamin you have to take? See, in the second line, vitamin needs call for at least 40 units of vitamin W. Okay. So vitamin W, you are getting it from both the food A and food B. Okay. From food A, you are getting, each gram is giving you 4 units. So A grams is giving you 4A. So 4A plus 10B greater than or equal to 40. Minimal you want 40. Okay. See, I'll tell you here. A plus 10B, right? Yeah. Vitamin W, you are getting it from both the foods, A and B. Okay. 4 and 10 units. Each gram of A you are consuming, you are getting 4 units. 4 units. Each 1 gram of B you are consuming, you are getting 10 units of vitamin W. Okay. You are talking of vitamin W here. Okay. So, am I consuming only 1 gram of A? No, I am consuming A grams. So, how much of vitamin W I am getting? 4A vitamin W I am getting. Okay, 1 gram of 1 gram of food A has 4 units of vitamin W. But I am consuming A grams. So, A grams has 4A of vitamin W. But vitamin W, I am getting it from food B also. From food B, I am getting 10B units of vitamin W. So this is the total vitamin W I am getting because of both the foods. And what is the minimum requirement? Say, I should consume 40 or more than 40, anything. Okay. So the constraint is greater than or equal to 40. Is that clear? This is the vitamin W I am getting from food A. This is the vitamin W I am getting from food B. Total W should be greater than or equal to 40. So, first constraint is regarding vitamin W. Second constraint is regarding vitamin X. Third constraint is regarding vitamin Y. Okay. Apart from that, you also have non-negativity constraint, which says that both the foods has to be greater than or equal to 0. Is that clear? Is the example clear? See, the problem he has given it in some statement form. If you can see, lot many numbers are there. Okay, everything you can sort it out in the form of a table. Then you can easily formulate the objective and the constraints. Okay, so objective will be asked in the question. See, find the least expensive way to satisfy vitamin needs. This is the question. Okay, so that becomes your objective. And the other things which are given before that will become constraint. Okay, you can see the vitamin needs at least 40 units of vitamin W. That obviously will become a constraint. Okay, is that clear? Is the
Yes, ma'am.
formulation of the problem clear? So
Yes,
this
ma'am.
is formulation of the problem. And
Ma'am,
after
but I have a
solving,
question now.
yes sir.
Ma'am, see at the end you have given vitamin after vitamin Y. What is A and B? Greater
Yeah,
than 0.
A and B are the number of grams of food A you are consuming and number of grams of B you are consuming.
Correct, ma'am. Yeah.
Okay, so number of grams, can it be negative? Can I consume minus 5 grams of food A?
No, no. Okay.
No. So it has to be greater than or equal to 0 only, no?
Okay.
Yeah. So that non-negativity constraint is there for every problem. For all the problems, that non-negativity constraint will be there.
So you mean to say for linear programming for this particular problem?
Yes, sir. Because the decision variables can't take negative values, isn't it?
Ma'am. Yeah, that's true, ma'am.
Yes. That's why non-negativity constraint will be there for all the problems.
Okay, ma'am.
So this, of course, you can see that from your study material, linear programming problems. So this is formulation of the problem. Okay. So here also he has given an example of the integer programming wherein the variables will take only integer values. Okay. So he has given some problems like, see here, the owner of a ready-made garment shop has 2 types of skirts, plain skirt, frilly skirt. He makes a profit of 200 per skirt. Excuse me. 200 rupees per skirt on plain one and 250 rupees per skirt on frilly skirt. He has 2 tailors, P and Q, in his shop for stitching the skirts. Tailor P can devote a maximum of 19 hours per day. And tailor Q, all these are constraints. Okay. See, time is a constraint, isn't it? So all these are constraints. Lastly, what is he asking you? How many skirts of each type should be stitched in order to maximize profit? Is that clear? Yes.
Okay, ma'am.
So what we have to do is, we have to tell him how many plain skirts the tailor has to stitch and how many frilly skirts the tailor has to stitch so that his profits are maximized. His profits are maximized. See, we may have some constraints. Maybe by seeing profit figures, you might say that he can devote only time to stitch frilly skirts only because it is giving you more profit. But business won't be run like that. You have some constraints. Maybe the frilly skirt is taking more time also. Possible? It needs more resources. Maybe you may have to buy some embroidery material to stitch that. Okay. So there will be some other constraints also, because of which it's not always the thing that's why the problem has come. I have to tell to this ready-made garment shop how many plain skirts he has to go for and how many frilly skirts he's to go for. Okay. So these are some of the problems which they have formulated and given. Okay. So you can go through. Maybe we are coming to the end of the session. So how these classes are, before for the last semester, the classes were on Saturdays and Sundays. But why this thing has done? Why only on the evenings continuously?
And we are also surprised.
Yeah, I'm also surprised. Today only afternoon, Radhakrishna sir shared this with me. And yeah,
Mismatch of management, madam.
much mismanagement.
Yeah, 100%.
Okay. Yeah. So first unit, you can go through the material. Okay, you can go through. I believe you will be able to understand. Okay, it's all theory. The different types of programming problems are given: non-linear programming problem, goal programming problem, which you will, I believe, you will be able to understand on your own also. Okay. Then the second unit is about linear programming problem, and I'll just go through the material syllabus. 1 minute. Yeah. Block 1 has introduction to operations research. This unit 1 you can do on your own. Okay, it will be completely theoretical. Just now we have seen. Okay, operations research overview. It will tell you about Second World War, how it has originated, and all the definitions and all will be there. Linear programming formulation we have done by taking an example. Okay, some more formulations we'll do it in tomorrow's class. Then third unit is about solving the problem. The one which we have formulated, we have to solve it, right? We have to tell to that boy how many movies he can watch, how many books he can buy, right? So we need to solve it. So there are two methods as we have discussed. Graphical method is there, simplex method is there. That will do. Then later we have primal and dual of the problem that is there in the unit 5. Unit